Okay, so welcome friends. This is a quick recap of what we did in so far in polymorphism. So we created two classes, student and faculty, both deriving from public person class, and then we had a virtual function in person class that we will call, we will not implement in the person class, but we override it in the derived classes or subclasses, so that whenever we want to call print, and if we have a pointer or reference to the base object, we could still refer to or point to a derived object, and then we can actually call the virtual method or the overridden method of the derived class, so that we can have a specific functionality executed specific to the derived class. So for example, in the faculty print, we are printing more details about the faculty which are specific to faculty, like department and salary, and in the student class we are printing information about the GP and major. So that's called polymorphism, where we are using a particular function has multiple. So in the student class we have functionality specific to the student class. Okay, so now in main what we did was we created a vector of person pointers, and so that because we know that we can do upcasting, and therefore we can actually point this base pointer can point to any object of any derived class. So it could be a student or faculty, and so we created a few objects of different types, different classes, different derived classes, and then we used a function to print all the information, and this print function calls the overridden functions of the derived classes. So therefore that's one benefit of polymorphism. Now there is one problem though, that if we have a virtual function, it's all fine, we can just call the function. We don't even have to worry about whether the person pointer is pointing to a student object or a faculty object, but sometimes we do need that information. For example, if the object is a faculty object, I want to do something else. I want to find out the salaries of all the employees or the faculties, and so I don't want to include the student object. So we don't have a mechanism really as such here right now that we can distinguish between or find out now, once we have the vector created and we have done the casting, that we can find out which object, or actually which specific type of derived object the pointer is pointing to. So to do that, what we will do is, there is one mechanism that we will do which is useful, is here in the protected in the attributes or the instance variables of the person class, which is the base class, we will add another attribute, and it could be an integer or a character. Just I'll use a character for now, and I'll call that type info. So this type info is essentially, we will assign a character, let's say S or F, depending on whether the actual object is a student or a faculty. Now we also want that as such the person object itself, we don't have much value of the person object itself. Like what I mean is, we don't want to create the object of person class itself, because that's not required. That will not have any type info, and we may get confused. So what we really want to do is use the base class, just so that we can have methods which we force, which are common, which we can expect the derived classes to implement, but we don't want to really create an object of the base class itself. And for that, what we can do is we can make class person what is called an abstract class. And how do we make a class abstract? Is we cannot just write an abstract class person or something like that, but the way to do that is, if we can create a function which is called a pure virtual function. So right now we have a virtual function, but it's not a pure virtual function. If we create a virtual function that's pure, and I'll show you how to do that, then we tell the compiler that this is a class that is an abstract class. In an abstract class we cannot create objects of abstract class. So how do we create a pure virtual function? Essentially we just say equals 0. So we create at least one virtual function which has equals 0 here, and when we do that, we are telling the compiler that this is a pure virtual function, and then I'll write this here, pure virtual function, and then we cannot create an object of this person class anymore, and I'll show you that in a second. So right now here now, because we did had a person class, car class, and car class has an object of person class, now we have an error. Compiler is saying you cannot create, you can see here, cannot declare field to be of abstract type person. So we cannot have an object that is we cannot create an object of the person class anymore anywhere. So we will fix this simply for now, because we are not really dealing with car class anymore. So I'm going to delete this file, and you know that I have this whole repository and previous versions on GitHub, Bitbucket, so you can actually download the whole code using Git. So I'm going to remove this, and you can see, if you want to refer to this code, you can check out a previous commit which has the car class. Okay, now that I don't have the car class, the compiler should be fine with that. So you can see we can still build now the code, and I'll still show this to you again. Now if I try to create a person object, for example person P, then I'll get an error saying cannot declare variable P to be of abstract type person, because person is now an abstract class because of the presence of pure virtual function. And another implication of making a pure virtual function is that if I don't have a function, let's see where, so if I don't have the implementation of the print function in the student class or any class that's deriving an abstract class, then I get an error. The compiler doesn't like that. So you can see this here. Then it thinks that student is also an abstract class, which is not the right thing. Essentially the compiler is forcing us to implement the pure virtual function in all the derived classes. So person class has a pure virtual function called print, and every class that derives from person, if it is not abstract, it must implement that pure virtual function, which is print in this case. So you can see the error is not very helpful, but we know what's going on. If I implement the print function, then you can see the code compiles fine. Okay, so those were a couple of things that I wanted to mention about the abstract classes and pure virtual function. And now the next thing I want to do is, in the student class, in the person class, we should implement we should make sure that the type info has some value, because that's the purpose of the constructors, that we initialize all the variables. So I'm going to say type info equals P, and if it's P, that means that it's a person object, which is not possible, but still we are initializing something. But actually what we want, important thing is, in the student class, in all the constructors, we will say that type info is S. So that's how we can identify that this this object which we are actually pointing to is a student object. So we can downcast it and then use it in different ways. So we have another constructor, so I'm going to pass type info here also, initialize type info. Same thing in faculty, we will have the type info equals F, and in the constructor again type info equals F. Okay, so let's build it right now, so we know that everything is good so far. Okay, so no compiler errors, everything is fine. Now how do we use this information? The way we use this information, one more thing we need is, in the person we need accessor method for type info because it's a protected variable. So we will say it returns a character type info const, and this method is going to return us the type info. Okay. Now so far when we call print here, you know that we can call the virtual method, and if I run this code it still works the same. You can see the person, we are creating objects, and then when we print information, we print information specific to the students and faculty, and appropriate print methods are called, and because of this function is virtual, or now it's pure virtual. But still here in this code we don't really know whether this object vector I, the ith object in the vector, is that a student object or a faculty object if you want to do something specific. So I'm going to create another method here, and we are going to do something different. So I'm going to call it process salaries. Okay. Now we have a function, we still pass the vector to the function, and what we want to do is now in this function we only want to process the faculty objects, and then if the object is a faculty object, we want to add all of the salaries together, so we know total salary we need to pay per month or yearly. So now we know that vec I gives me the object, but then we can find out what's the type info. So if the type info that returns me the character value is F, so if this is F, then for now I'll just say cout faculty object, and at I, so that we know that that a particular place there is a faculty object. So I hope you understand this code. We are not really downcasting yet, but we are just saying if the object is of the type is info, we know that it's a faculty object. And to make it a little more interesting, what I'm going to do is I'm going to push the student object later on, or in between the two objects. So let me delete this code here, and then I'm going to put this in between. So we have one faculty object, then we have a student object, and then another faculty object in the vector. And I'm going to comment the print info, and I'm going to call now process in salaries vector. So we pass the vector to the process salaries function. Process salaries function will take the vector and then check and tell us which object in the vector is a faculty object. So we have an error here. Let's see. Okay, sorry. So vec I is a pointer, so we need an arrow here because this is a pointer. Vec I, the vector is of pointers, not of objects. Okay, I hope it should compile now. Good. So now when I run the code, you can see here the output. We have 3 objects getting created, and then when we print information, the faculty object, we have 2 faculty objects, one at index 0 and one at index 2. So it looks like our code is working fine so far. We know which of the objects are faculty objects, and now once we have identified those, now I'm not going to print that. Oh, let me print it still. What we want to do is we want to downcast it to a faculty pointer. So faculty pointer, and now we will call it faculty equals, and we know that vec I is a pointer, but this pointer is of person pointer, so we need to convert it or cast it to a faculty pointer, and then we need a parenthesis here, So okay, and now once we have that, now the faculty object is actually pointing to a faculty object, so you can see we can get access to salary. And I'll show you this. If I just have a person pointer, which is also easy to do, we don't need a downcasting in that case. I can just say vec I. So when it's a person pointer, we only get access to the methods which belong to the person class. But when it's a faculty pointer, we have access to all the objects of the faculty class. So now you can see here we can get access to salary and department and all that information. So now the next thing, as I said, we want to create a total, so we will create a double sum, initialize it to 0, and then we will add sum plus equals to faculty.salary. So, and then let's return this information here. So we return the double in, and then after the for loop we return the sum. And now in the main function we will cache that value in a variable, and I think that's a good idea always to do that. And then we will print this total salaries equals. Okay, so the code compiles. When I run this, you can see we have faculty object at 0, faculty object at 2, total salaries is 250,000. We can confirm if that's true. One faculty 100,000, another 150,000. So looks like the total salaries is coming out correctly. Our code is compiling correct, and then we have the output is also correct. Okay, so we will pause here and then we'll continue more in the next lesson. Thank you.